simple interest as first order linear recurrence relation. It's exactly the same as flat rate depreciation, whereby the flat rate, so this is how we did the flat rate. Just gonna get this one here. That's better. So the flat rate, we use this formula, and rather than minus, it's going to be plus with the symbol interest. All right, now, and our initial value, whatever initial investment was, in this case here, is actually 325 for 5 years. So we want to find out, we want to set up a recurrence relation to calculate the value of the investment after n years. So that's going to be Vn. So that's our initial value is $325, and whatever the initial is. So if I want to find out the next, so this is the next term, the previous term, plus the D. The D value is going to be R over 100 times V naught. So in this case, it's going to be 3 over 100 times 325. So you could use so this is going to be $9.75, $9.75. So now this is, we have set it up. All right, that answers A. The next part of the question is asking us, use the recurrence from part A, relation from part A, to calculate the value of the investment at the end of the first 5 years. So we have to use recurrence, so that means we have to use the previous term in order to obtain the next term. So let's use the calculator here. So put 325, press enter, plus and $9.75. And press enter. Just keep press entering. So that's going to be the first year, second year, third year, fourth year, fifth year. So that's basically what you're going to do to obtain what the question is asking. All right, now let's look at another example. So now Jan invested with a building society $210 in a saving account that pays 8% simple interest for 5 years. Use the simple interest rule to determine how much was in our account after 5 years. So we could actually use that by doing this, and exactly what we did. So we need to find out what the D value is. Remember that. Again, let's write it down, everything that's given to us. So this is the formula we need to use. So R over 100 times V naught, and our R value is 8 over 100 times V naught. So it's going to be $16.80. So that's how much it is going into the account. So now we want to find out how much. Use the simple interest rule to determine how much was in our account after 5 years. And now we could do that graphically, or we could, so to do that graphically, we're going to have to use, so it's exactly what we did. So we're adding $16.80 by going to the spreadsheet. Let's go back to our CAS. Alright, so here's the CAS. And press Control, the doc, the spreadsheet, and the initial. So we want to find out, so this is time. Alright, 0. So that's where it started from. 1, 2, 3, 4, 5. So initially she had $10, so $210. So we're going to call this one as future value. So because it still remembers this, I'm just going to call it future value 1. So initially she deposited $210, and every time it was adding and So put the equal sign. So every time she was adding $16.80. So 210 plus $16.80. So I want to keep that $16.80. So I want to put the dollar sign again. Actually, didn't keep that one. So what I want to keep, I don't want to get rid of the dollar sign. Actually, that was, let me just do it again. Get rid of the dollar sign. Let's take the in. So that's better. All right. So now here, every time, so it's increasing by, we put the formula here actually, much easier. So we have that, and we are increasing by, so that, and plus that, we're increasing by $16.80 times and the times the years. So basically, so that means, so if I multiply that, so A2, so that's going to be A2, enter. So we want to make sure that this initial cost, well, this has to change because we have to use, it's a recurrence, so that means we have to use the previous one in order to get the next one. You can just fill it, menu 3.1, menu 3.1, and that fills up for us. And you can keep doing it. Menu 3.1 again, menu, until you fill it up, all the numbers, all the cells, I should say. Yep, and that's how you do it, simple interest.